Hey, and welcome to the Unreal Engine News and Community Spotlight. So first off, we'd like to highlight a project by 51VR based in Chengdu, China. So they actually crafted this photorealistic city street for the purpose of AI training. So this scene is all rendered in Unreal Engine. They took over 3,000 3D photos and pieced them all together on this 450 or 440 meter stretch. And the idea here is that they can then use that to train their cars and things, or their AI systems for autonomous driving cars. The team was able to throw this together in a month and a half with about 5 people. It's running at 40 frames per second. They've got over 5 million textures and 2 million shaders. So it's really incredible they were able to put this scene together, and it looks absolutely stunning. They have a full write-up. I definitely recommend checking out. It's really, really cool. Previously, we mentioned the VFX seminars that were going on in Los Angeles. So these were put on by the Noman School of VFX, and the master classes have actually been posted live. So you can go take a look at those. They've shared them. The first one's kind of on, it's a big picture of performance and workflow. They also talk about pipeline fundamentals for VFX. And then the second one's on rendering and sort of best practices for profiling techniques and things. So those are online. And if you missed them, or if you're interested in seeing them in person, they'll be doing them at the Vancouver Film School on March 3rd, so go sign up for that. It's actually included. A link to that event registration is on the blog post for the VFX pipeline, or the videos for that. Next up, we also have another webinar going on. So next week on February 22nd, there's a 4th and final installation of the VR and AR design webinar by Chris Craigbar. If you're into that or trying to follow up, that's happening next week. Definitely check the link out for more details there. We also have an interview with Usman Iqbal from he's the head of production for Allahyar and the Legend of Markhor. And it's such an amazing feature film that they've done. The team's based in Pakistan. It's 100% created in Unreal Engine, and it's just a beautiful, beautiful film. And he kind of talks through their process and how they are able to utilize the engine. So it's a really fascinating interview, and I definitely go check that one out. And last but not least, we'd like to congratulate all the UE4 devs, or the UE devs that were at the Lumiere Awards. We had 4 folks that took home awards that night: the team that created Tree, Raising a Ruckus, Altered Carbon, and the Spider-Man Homecoming VR experience. Super congrats to them, but we also want to give a big shout out to all those that were nominated. There was a lot of really amazing content at those awards, and so great job to all those teams there. On to our weekly karma. These folks are really jumping in, helping serve their community, and just answering all kinds of questions, and we want to send them some love. So thank you, and to I Create Art, GenVE, Deathray, Dune, Thompson In13, Chromarict, Exxon Flex, Firefly74, Ali Akbar, and Maki Girl. You guys, you're just great. So on to our community spotlight. The first one is a project called Warriorb. Warriorb. And it's this really cool, it's a spline-based side scroller in a 3D environment. So it's you're running through, trying to dodge these deadly traps that you could encounter. And there's ones that slow down the pace by jumping into puzzles instead. Just really like the look and feel, and want to give a huge shout out to them. It looks great. I'm excited to give it a shot. The characters are really fun, so great job. Our second community spotlight is a project called Mount Shuksan. It's based on the Shuksan Mountain in Washington, and so it's a view from something called Heather Meadows. It's just a really beautiful scene. I think he's done a great job rendering out this environment here. And yeah, you've done a great job. It's so pretty. And our third and final project it's just called the Libyan Desert. It's the latest 3D environment by C. Prelate on the forums. So it's just this ancient Egyptian column ruins in this oasis, and they're just experimenting with their sand rocks and landscape shaders and whatnot. And really like to see these kinds of environments. It's so beautiful, and yeah, you're crushing it, man, killing it. And they have more walkthrough on their ArtStation page, so do go take a look at that. It's pretty rad. All right, so thanks for joining us for our news and community spotlight. Hey, welcome to the Unreal Engine live stream. I'm your host, Amanda Bott, and with me today I have Alan Willard, our senior DevRel tech artist.
With a title this big.
Yeah, we have a
You'll
much
notice
abbreviation for
they've
it. Lauren, who joins us again, our tools programmer, and Chris Bunner, who's a first-time live stream guest, who's one of our senior rendering programmers. So thank you all for joining today.
You're welcome.
I think we're in for quite an adventure this afternoon.
An adventure, sure.
Yeah,
We put it that way.
So we're going to go over material layers, which are a new experimental feature coming in 4.19.
Right.
So what makes it different than how folks have layered materials in the past?
Right. So before, when you had a layered material, which we've got examples of, in the documentation and in samples, you end up with this giant material graph. And so if you want to change what one of those layers is, you've got to either, do some static switches and have an even bigger material graph, or create, another similar but not quite the same material, and it just gets very clunky.
All of your instances get invalidated every time you edit, things like that. It works, but it's pretty hard to. Like, the further along your project goes, the more difficult it is to iterate on.
Right.
So.
Well, not to mention, because of the way we do material layers currently, a lot of it gets embedded in functions, which are more difficult to pass variables into, right? You create an instance, you have to expose any parameter you want to change inside the function to the shader above it so that the scalar and vector parameters can make those changes. So this is, there were some workflow issues that really needed to be addressed.
Right. And the hope is that when you're making these modular layers and putting them together in materials, you can actually end up with things that are cheaper over time. If you end up with like a lot of skins or weapon variants that have things that are, again, mostly very similar but with a little bit of difference.
Yeah, so the idea being, it's a higher buy-in cost to set up your initial library probably, but the further on your project goes, especially doing like Lauren said, customization, skins, variants, things like that, it should become cheaper as time goes on and make it easier for artists to reduce shader complexity, reduce shader counts, to optimize individual layers and not have to rebuild 10 materials on top of it.
Yeah.
So.
Not to mention, because the way the layers work in the newer system, each instance of this layer hierarchy, all of those parameters can be changed individually without polluting the original material, which is a problem with the material functions, in that if I need to make a change to how the layer functions, like I need to expose another variable, that can affect everybody else using that layer.
Yes.
I can't easily just create n number of variations and just use them. And this is a much more straightforward system for doing that.
It's always been a long-term problem, especially that if you use material, so for example, if you use the old layer workflow and you have a wood function, you can use that in a material, but if you want to have a material that had 2 wood layers in, you couldn't easily set different parameters to have 2 kinds of wood in the same thing, whereas with this system you used to have one unique graph and then you just stack and override them.
And everything's nicely instantiated, so your 3 different wood layers or 2 different wood layers or 1 all have the same parameters, all of them can have a different setup internally, and then you can choose how to blend them with each other in any way you choose. So it gives you a lot more flexibility with how you use the layers, as well as what the layers actually look like in your final result.
Yeah. And I think we were talking earlier about how blends are like kind of the stealth power user thing here, because if you've got your blend set up right with your masks or maybe roll displacement for like the snow effect, then you can swap out anything you want in one of the layers and kind of get that blend without having to know how it's set up if it's doing what you want it to do.
And not to mention being able to have parameters inside your blends. So like currently, if you did blend 2 layers together, that tended towards the static because of the way we're using functions and things like that, whereas now a blend really just looks like a material that happens to have two inputs, both the layers that you're blending together, and then your logic just drives that. You don't have to worry about a function. You don't have to worry about parameters being invisible because they're inside of a function. It's all right there. You can see as you make changes. And it's actually really easy to use, which we'll be showing in a few minutes.
I think we
Any
definitely.
questions, Sue? Should we just go ahead and pull it up?
Yeah, I think we can go ahead and pull it up. And while that's loading, I think another thing we wanted to stress is that this is experimental, but it's also like we're still developing. Like, you know, as say Alan's using it and going, oh, this would be actually really helpful little tweak to have in there. It's something that we're taking into consideration as we're getting forum feedback, things like that.
So, because 4.19 is our experimental release, 4.20 is what we're aiming for a real release, and we've pushed for feedback in as many avenues as possible, and there's still quite a few problems to solve. And so, if anyone is using this, please post on the forum threads. I mean, all the feedback is very much taken into consideration. Post comparisons to other tools you've used and workflows that work. It'll definitely help drive the finished product.
Yeah.
So here we've got some content that one of our designers here, Mitchell, put together so that we would have things to demonstrate. So it's clearly the same mesh across the scene, and then there's three different material instances, and those material instances are driving all the layers. The core material looks like this. So it's really, really simple. It has a new layer node, and that's what tells the whole system that this will be material that can be blended together with layers. And then it's got a couple of textures hooked up for various parts, like blending the normals together correctly and adding the ambient occlusion. And then it just goes to the same material attributes node that you're used to using for any kind of shader. Where this starts to get really cool, though, is when you start to make instances of it. You still have the details panel, which has any parameters that are part of that core shader that I just showed. But now we have a layer stack here that allows you to define a background layer. So whatever the behind the scenes object is, I'll change this to be the actual mesh so we can see it a little more clearly. So in this case, the background is this carbon fiber material instance. And then we've got layers which have been added by I assume Mitchell. I didn't create this particular one. And the nice part is each layer has not only the layer itself, but also the blend. So these are separate assets. I can define a layer completely independently of how it's going to be used at the end. And then my blend is where you can get into some really cool stuff with how these layers are being stacked, which attributes are being passed along, and things like that. So a layer looks like this. This is a little more complicated than the base shader, but all it's really doing is defining some texture samples, how they're being used with totally normal scalar vector parameters, anything you want, and then being passed into another material attributes node. Now, it's important to note, this is not your traditional material. This is a material layer, so if you don't have the experimental flag on for material layers, you won't actually be able to create this. So it shows up under material and textures as a material layer, but the shader editor itself for this is identical. Once you've defined this layer, you can then create instances of it, make as many variations as you want, but then you can throw those into this layer asset here. Let's say change this to snow. And now my first layer, after it recompiles, is snow. It's that quick. You can just throw whatever material layer you want in, and as long as you don't exceed the number of texture samplers or whatever, it will just work. I'll put this back to my...
You want some snow armor?
Chrome. I don't want snow armor. I want chrome armor. I like chrome armor better. And you can see it's cached that, so switching to this is really, really quick. And then this layer asset will roll out, and that's where I can see the parameters that are defined in that material asset. So I can tell how much of the normal is being used, or change the tint. And again, I'm not polluting any of the layer behavior. I'm just instancing it inside of this layer editor, which allows me to set these up completely uniquely, where I can change which mask is being used. So you can see really quickly. I can completely change the way this looks in just a matter of moments. There.
Shiny.
Shiny.
And so what's happening is this stack is being built out into a material graph under the hood. So, you know, you're not really, as long as your materials, the complexity of materials doesn't change as if you were to have that built out in the material. It's just, this is a much easier workflow.
Yeah,
Right.
yeah. I think that's an important concept to note is when you say material layering, there's obviously a lot of different concepts of how to do that. This one isn't like a multi-draw or a multi-pass system. This is intended to, as Lauren said, what you're supposed to do here is build a bunch of small isolated graphs that you can tweak, optimize, parameterize correctly, and then you take the layers and build them up, and under the hood that will go through and build your graphs and put the blends in between each layer, or you can do things like hide and show layers. You can make opaque layers when you're testing and debugging. So at the end of your material, when you finish and you've made your layers, you should end up with a single material and a single draw call still, as much as it ever would have been. So it shouldn't be any new costs. This is mainly focused on a workflow improvement at this point.
And as I'm playing around with while Chris is talking, I've changed my layer to this just cobblestone layer I made really quickly before the stream. And I can change all the blends. So I can say leather is on different parts, carbon fiber is on different parts. So while this is much more of a traditional stack in terms of how the layers are blended, you start with the background, layer 1, layer 2, layer 3. It's much more conceptually familiar if you're used to using something like Photoshop, where those blends are sum up in that same way, right? You have your background, whether it's a color or an image, and then you start to add elements as you're working. The same exact thing is true here. So let me set my blend back to alpha here.
I saw you were toggling the visibility actually.
Yep.
While we were talking too.
There. So I can show that a bit. So here's my layer stack, and you can rename these. So if I want to say this is leather, I can remember that. And then expanding that, I can go in and change all out the contents. You can also change like the, as I said, the different alpha channels and things that are used. That's contained in the blend asset, and this is one of the things that when I started using it, I got pretty excited about, because it's great to have materials being put together on a surface, but where you can really get into some interesting stuff is how you're blending these materials together. So this is just a little thing I put together. By default, there's a checkbox for automatically creating some of this node graph when you create a blend or layer. It has the input for the previous layer and the next layer and how it's going to blend these together. And then we have a number of functions that we've already created for choosing how to blend. So there's a lot of the more traditional Photoshop type blends available already. And then we also have things like simple LERPs, which is what this is. But I made a little bit of a shader graph here to let me kind of do a little carbon fiber-esque blend. So I can just change out the blend here. There we go. So now my top leather blend is coming from that weird carbon fiber thing I did. And I can change the tiling a bit here. And I'll hide the other layers. So we're just blending the carbon fiber and that leather, but it's all angle dependent. I was able to do this really quickly, and so you can extrapolate from that. I could do blends based on the roughness of the previous layer. Anywhere it's not rough, come in. If I wanted to do something along the lines of a wetness, so if you wanted to have a shader that says, here's how wet something is based on the blend, and then the layer that gets blended in is the wet version, and then procedurally drive that the parameter for wetness, all that stuff would work. And obviously there's other blend types you can imagine, things like a simple vertex mask. So you say, I want to be able to paint this, and red will blend these two layers, green will blend these two. All that's really easy to set up. And then it becomes very extensible. you'll notice that up here in the layers browser, there's save sibling and save child. This lets you take the current state of your layer with all its blends and all the variables you've set and create a child or a sibling that has all those properties. So a sibling would be, it has exactly the same parent just with different settings, and a child would be, it's inheriting any settings from this one. So if I make changes to this and the child doesn't override it, it would pass those values down.
Yeah, but things for like, you know the roughness of your bottom layer, and so you want more grime there. You can definitely have that be a blend.
Exactly. You can do things that are much more conditional, where it looks at whatever the instance defines and then passes that down to the blend, which in turn affects the final result. And clearly, we've made a couple. You can see what the layers here look like. Turn on the background. So all of this, it becomes very easy to work with, especially as you build up a library of blends. You start to look at it as, I'm going to grab this attribute and only that one and use that to determine how my layer stack is going moving forward. I've been experimenting with some of the characters from Paragon, which used the previous, much more monolithic layered material system, and it becomes really apparent that being able to swap out any individual part of that is a huge win. Because when you have that 10 layer stack for like a Paragon character or a Fortnite character or whatever, making kind of razored changes where I want to go halfway down the stack and move something around is really, really time consuming, and you have to make a duplicate of the shader and swap things out. Pray that there is a material layer that does what you want already. And this makes all of that much, much easier, because I can just swap out the contents of a layer and it just works. Or I can change how the blend works so that the stack resolves in a slightly different way.
Or you were saying for characters, you mentioned like, you'd have the same 10 stack, but you would just change out the blends for, say, an upper body piece of armor, or the outfit versus the lower body, to have something that matches.
Right, and it's also important to note that the base shader that you're using, you can view those as global properties. All of those properties can affect how that base shader works in addition to the layers. So say if I am building a complex character shader, but I know that I'm only going to have like one or two normals, and my instances really need to change those normals for like top half, bottom half, or armor versus skin or whatever. If you put that normal map in your base shader, everything will inherit that. So if I change that, my instances will use that normal for them. So I can do the exact same layer setup and just change out the normal, and my character looks completely different.
Yeah.
Or put all my masks for how I'm blending the different elements into the global shader, and then just inherit those for all the children, and then I can change out 10 different characters by just changing out a couple of masks that determine how things blend.
And everything here as well, the standard materials and material instances, so all the normal rules apply. You can make an instance of an instance and so on, and so that can affect how you would build your hierarchy for things. I think you showed a good example of what we were talking about earlier as well, of how you need to build up that library. Like, for example, you have 3 blends or so in that particular folder. There's a lot of standard ones you'll probably make very quickly, and then as your game goes on, you'll throw in an extra one, and then you'll just drop it in here, there, and it evolves quite organically, but that initial setup time might be a little slower.
And you can also do really complex blends that are parameterized. Like if I have something that uses the red channel of one mask and then uses another one for adding like scratches or grime or something like that, that can be done in the blend as a parameter. So I have a utility blend that can be adapted to the specific use case I need, whether it's changing out which channel is being used, changing out the texture, modifying math like multiplying and powering it and clamping it and stuff like that. All of that is really nicely parameterized inside of that layer stack in all of the instances. So it's really easy to make something that's very broad in terms of utility and use, but is really simple and easy to actually interact with once you get to that point.
Yeah.
I was just going to add, because it was in your examples used fairly heavily, one of the new material expressions we added in 4.19 is a channel mask selection, and that's a dynamic parameter that will let you swap which mask you pull from a texture for a single instruction.
Link down one.
So it's especially in these kind of workflows, it's very, very useful because a common thing you'll do, for example, is you'll provide one mask that you'll then pass into multiple layers, and each layer might pull a different channel. So it's very nice to be able to very cheaply and easily do that without having to recompile. And if you want to change it at runtime, like say if you had a damage mask and you had multiple masks in one texture, you can compile that down and swap the channel that's sampled at runtime.
Yeah.
That's
So-
actually being used inside of some of these blends. Like
Yeah. So
this
that
drop down
that new one there.
is exactly what he was talking about.
Yeah, and it's just a one instruction single parameter, so it's quite a nice one.
And we don't have the blueprint support for driving these yet, but
yet.
we do want to make sure that that's in before it
Mhm.
leaves experimental, because
Yes.
obviously you don't want to drive things like, damage or something like that from
Yeah.
gameplay code. So
And the children and sibling thing I was talking about, like if I decided I wanted to make dramatic changes to this, but I was really using this as my core, I could just say, save a child. It prompts me for what I want to name that. And then I should have my new child in here somewhere. Here it is. So now it's any changes I make to the parent will be inherited by this until I override those. But then I can make changes at this layer and say, override this and go bright red.
So speaking of layers and children, if you save off the child of one of your layers to show the filtering side of things, like the fact that if you, right now, if you were to swap out one of your layers with one that has the same parent, is in the same inheritance tree, it's actually going to be cheaper because you're just swapping out those parameters.
No, because there's only a few here, none of them are set up that way. But this new little icon tells it whether or not it should use this, look for other children of the same parent when you're swapping the layer out. With it on, I only see the one because it doesn't have any siblings or children. Otherwise, I would just see all the potential layers that I could swap to, like paint. And again, this is still has the same parent. The child has just been changed out to be a different, have a different layer in that particular slot.
Right. But yeah, we think of that for like if you have a bunch of metal layers saved, and if you swap them out, you're actually going to be having a cheaper instance than if you were to swap it
Yep.
from, say, metal to paint. So
Yeah, the idea it's as with other instances, but on top of the layer system as well, is that exactly that. With say there's multiple armors there, you can save out a whole hierarchy of different instances, and if you don't change static switches, you just make a bunch of param variants. Especially like we were talking about earlier with a layer, like say if you had a wood or a metal layer, you might have a metal layer that's like a base shader, and that has a cost to having it. But everything past that, you might just make children where, say, for example, you tweak the colors to make like a gold, a copper, and so on, and then you can make a whole hierarchy of those and add that filter, and then easily swap them.
yeah, I want that one.
You're more than welcome to have that.
Looks
But
like
I
a
mean,
laser tag.
like I said, it makes it extremely easy to build something that's very powerful and complex, but has a really recognizable instancing system that lets you just work with it at that level. So it becomes very compelling to have tech artists or art leads build the kind of workhorse shader graph that does all the heavy lifting, and then the artist can just go bonkers changing layer setups, rearranging things, and come up with really, really stunning variations off of this library that the artist can build.
I mean, something that I like, because I don't really use materials that often, but I was playing around with this system after Mitchell sent it over, and at least not to the level of, making lots of materials. I'll make the tools for them. But I was able to kind of make a little test material that I found in docs and swap it in as a section in the armor, and it just worked. And I was like, okay, I only have to figure out, this little part that I want to tweak, and then the rest kind of comes from the graph setup,
So
or from the layer setup.
I'll go ahead and set up your snow.
While he's doing that, I wanted to clarify as well. So one thing that we added in this as part of the whole layer blend and everything else is that traditionally with materials you can make instances of materials, but with functions you couldn't make instances of functions. With blends and layers you can. So with our kind of discussion before, where we were saying, you'd have these instances, and when they're doing, say for example, on a particular layer, save as child, that's saving an instance of that particular layer, so it uses the same subgraph that gets interleaved in the same way, and it just brings in those overridden parameters on top. So you can make some pretty complex libraries pretty quickly, and pretty cheaply as well.
Yeah.
So there's your snow-strapped armor
Thank you.
with time-varying color metal.
Yeah.
But again, it becomes really easy once you start thinking in terms of layers and blends instead of just one large graph with a bunch of parameters that can be adjusted. You start to see it as a tool chest instead of just working with shaders. You're just plugging things in, and oh look, I'll just change the way the stack resolves, and it looks great.
Yeah, and having all the parameters exposed on that level is a huge deal because you also really couldn't do parameters in
Yeah, I mean,
before.
material instances that had material layer functions in them could get a little confusing in terms of what's exposed, and having parameterized values inside of a shader function that you needed to get to meant you had to change the function and create function inputs and outputs, and it could get really complex. Not to mention the way the current material function layers work, they're not independently instantiated.
Yep.
So if I'm using it in a shader and I change something because I decide the appearance isn't quite right, it's going to change any shader that uses that material function in it, which is great when you've got everything locked down and you can make optimizations that inherit down, but it becomes problematic when you're just trying to do like appearance variations within a known set of characters or whatever.
Yeah.
Whereas this lets you ideally still do the optimizations because you still have that small subset of core graphs, but you get the benefit now of this
Right.
unique
All of my
unshared
variations
parameters.
come
Yeah.
more natively from just the artist workflow, not from going in and making essentially code changes to the way the shader works.
Exactly.
Plus, you can have 1,000 different instances of one thing and swap between them very quickly, and the better insight into the parent-child inheritance when you're inside the shader. This particular example doesn't show it because we didn't have a bunch of them made, but it really becomes very useful when, like, I have 10 different leathers made from the same parent, and I just want to pick between one of them, and I know that all of the variables are going to be the same and all that stuff. It's really fast to just choose one, and it doesn't require a recompile as long as that parent is used in the graph, and so just kind of experimenting with things becomes really, really, really fast. The iteration is really quick.
And if you, say, picked a kind of leather and you're like, that's almost it, but not quite, you could tweak one of the parameters and then save it off, and then you've got,
Yep.
another library layer. So,
So many things.
do we have lots of questions?
There are some questions.
Do we have any?
Yes.
We haven't answered any yet.
Not yet.
We've
Well,
answered
I
our
mean,
own
you've probably
questions.
inadvertently answered some questions.
Well, one hopes. I mean, if you're adequately explaining something, hopefully most of the simple questions get answered that
Right.
way.
All right. Let's see. Let's start at the top. They want to know how they're suitable for landscapes and things like that.
We knew this question was coming.
This day would
This
come.
This is
So-
Chris's moment.
So, when they're finished, right? So basically, so the important thing to know about material layers and the layering system we've done, as I said earlier, is that under the hood, what it's doing is it's just making a graph in the same way you would have previously made a graph. So there's nothing stopping you from using any existing feature or using them for any things. You can use them for decals, you could use them for landscape or whatever you need to do. Even a post-process graph should work really with the layer stack if that's what you want to do. Because ultimately it just makes a single material under the hood, so there shouldn't be any major restrictions. Right now there might be some conflicts and we'll have to look into that, but long term, by the final release, it should work with anything, yeah.
Yeah, we were talking earlier, and we were saying, like, as long as you're using kind of that landscape data to drive your blends, then you should be.
Yeah, I can foresee having a specific blend type that is a landscape blend. It understands that it's not actually kind of doing the stack. It's just allowing that layer to be blended in when the weight map from painting on landscape is in use. My guess is we'll have a slightly different UI for it since it won't be a traditional stack. But Yeah, that just the having the concept of arbitrary layers as a user editable stack rather than a giant set of material functions is really, really appealing for a lot of the kind of workflows that we've been using for a long time.
Cool. Now, you kind of touched on it earlier, but is it any faster in terms of performance, or it's just sort of the same as before, but we're restructuring? It's purely
It's mostly workflow, right? It's just like if you made one material the old layered way and one material the new layered way, you probably get comparable cost. It's more like if you're going to make 20 of the old way and 20 of the new way, you may be able to find cost savings because of how the layering works.
I think having a solid understanding of what the old method used to do and how that would force you to build your materials and build multiple shaders and things versus now, and how much easier it can be to, especially like Alan was saying, stick within those hierarchies where you're not generating new permutations and keep an eye on that. That should be easier to do now. So if anything, it should be easier for you to keep the material counts down, but the individual materials themselves should be identical.
It really does. It promotes a better workflow in terms of not creating 1,000 unique shaders when within the layer stack you can just easily choose to pick only children. So you can stay within that kind of known walled garden of everything. Everything I'm using is safe because I'm using the children of well-authored parents.
Yeah.
And, obviously static parameter switches can always begin to turn on more expensive stuff. So there's some definitely going to be an awareness of what the shader is doing under the covers if you're doing anything really kind of out there. But again, for the average artist who is building a texture set to build a material set and doesn't need to spend half of his time building shader graphs, this is going to be a massive win in that you just have a library and you just put them together and kick them out as new shaders.
Nice. They're wondering, will it break or not be compatible with previous versions that they've used, like projects or anything, or it's just very...
It's in parallel.
Yeah.
Yeah.
I mean, I have, in test cases, I have old material layers, individual materials, and then the new material layers all in the same scene. So
It's right now in 4.19 it's opt-in because there's a few performance penalties, but we'll clear those up and turn it on by default in 4.20. And ultimately, the node that Alan showed before, where it's that layer node, that represents your stack, and you can have a full regular material do exactly what you want to do and just drop in that one node as and when you please, and internally that'll go off and do the whole layer stack and expose everything to the instance editor for you. So yep, should be totally a-okay.
Put things before the node and feed them in, and put things after the node and sort of put on top.
Yep.
yeah, and that's something that I didn't have a clear understanding with until Lauren and I talked about it yesterday or day before. And it's actually pretty important because you can see here the layers. You can actually choose to get a material attribute, and this is say I just want the normal. It's very, very small on this screen. So I'm actually getting here's my entire layer stack. Here's the results of that in the normal channel of the material attributes, and I can completely choose to ignore that. So I could literally just step around that, and instead of getting it, I could set. And because I know that that layer stack is coming in before I'm doing this, I can just set my own normal here, and all of the parents' normal information just gets stepped around. This would break other things in the shader, but that lets you kind of have the final authority be in your base shader of what's going to happen, and then all the layers set up everything leading into that. Or like Chris was saying, you can do, and Lauren, you can do that after the layers have been set or before. So you can choose to have the layers be authoritative or whatever's in the shader be authoritative, and have them blended together in really unique ways because it's all being defined in the base shader, not just in the layer stack.
Yeah.
And again, properties that are set in there show up in the traditional detail panel here, just like you have the opacity override and things like that. You have variables that can be set that affect the global parameter or the global shader.
Yeah, I think we started going with like, I guess, global parameters, kind of separate them from the within the layer, within the blend
Right.
parameters when you see them in the UI. So.
All right. Will layers that use identical textures be seen as one texture call or multiple?
That really depends how you author it. I mean, if you're sampling the same texture with the same, the same like texel, that really depends on the compiler and what it decides to do. We're certainly not stepping in there. So right now, when we glue everything together, we don't necessarily perform any kind of post-analysis on your graph and try to optimize it. We could, I suppose.
And just for making sure your texture samplers are shared as long as there's nothing like unique to the texture sampler that's being overridden. That would be.
I mean,
I can see that being useful to do.
I mean, you should. So if you're using, if you have multiple layers that use the same texture and sampler type, that will be shared. But the specific, call in the shader code to say sample this pixel, that will be duplicated. But if it's identical, the compiler will probably do a good job of getting rid of that for you.
Right.
But one thing we've not done with this. So right now, the main focus is all about workflow improvements, and we've talked a lot though about moving forward. Well, now we kind of have a better understanding of your material and what it is, and the blends and things like that. Can we start to add in optimizations where, say, for example, we hit an opaque layer, it's blended on opaquely, we can skip the rest of the graph, and that's not something we do right now with this first iteration, but it's definitely something we will be exploring down the line.
Yeah, if it's something
That'd be
that
really cool.
isn't dynamically driven, because I think we're talking about this, and it's like, it could be something that you drive the alpha programmatically, and then we wouldn't be able to do that. But if we know that your alpha is always
basically
one there.
you turn the layer on or off, and it understands how to do that dynamically.
Yeah.
And you can see it kind of does something similar in that it is caching certain behaviors. So if I turn, when I'm looking at the layers, when I hide them, it compiles it once. And once that's complete, I can toggle that on and off because it's kind of storing both states, and I can jump back and forth. Here, that's just transient content that gets created dynamically while I'm editing, and then all goes away when I close the editor. But that concept of it understanding that this layer will be on at some point will come in really handy for things like that.
Yeah. But it does help to visualize of you're trying to figure out what part of your material, your final material, is coming from which layers, and we want to add some more, even just to the UI for that, to be able to kind of really highlight, okay, I can see where layer 2 is changing things.
Yes.
Yeah, and we've been discussing internally different UI improvements for making it easy to work with, and we certainly want feedback on that. I mean, this is exactly the point in time where if you're passionate about how layers should be represented or what kind of tools should be built alongside it, now is the time to provide that feedback.
Yeah.
And we certainly have some internally, and we're not, we don't always see every possible way of doing something, and sometimes we don't see the best way. So your ideas are always valuable.
Well, and you've started or Tim started a forum.
Yeah, we have a
post.
forum thread.
I'll drop that in again. I already shared it once in the chat earlier, but there's a thread that's kind of outlining a little bit of material layers, and then, they're collecting feedback of how to build it because it is experimental, and we want to know how we should move it.
Yeah, I mean, even if I were to look at the UI from when we first started to now, it has changed so much, and it's even changed more since then. We don't have that built on here. But, the thumbnails now will update as you adjust the colors, so that really helps you preview.
Thank you for that, by the way.
You're welcome. I'm just sad I wanted to get it in before.
Well,
the show.
that and being able to name the layers so that you can just look at the stack and go, okay, that's my carbon fiber, or that's my whatever. In this version, this hadn't been done in these things. I can clearly go in and do it, but being able to kind of see what's going on
Like if you change the tints.
from this view and know that my carbon fiber is tinted pink because the vector parameter was set that way.
Yeah.
That's the kind of information we want to be at kind of a high level.
Yeah. So we're working towards that kind of thing of just being able to, if you've got especially large stacks, to be able to kind of drill down into the part you want, because that's
well,
the
the Paragon character, it's 9 or 10, 9 layers plus the base, and that fills up a good portion of the screen, and when you've got a couple of those layers open, it's a big scroll to go up and down. So the more information you can get at a glance, the better off you are.
Oh, they were wondering can you propagate your child parameters back to your parent?
So that's something that's on my list of like almost just making the parameter thing more of a collection that you can just take and then put on anything that's got matching sets. But not right now. Right now it's all just progresses, from parent to child to grandchild. But it's definitely something that's come up before of just being able to like take it more as a set of parameters that you like and applying it in different cases as long as that family tree works.
Sweet. They're wondering if and or when can we expect dynamic parameters for MDIs?
So that's probably more of a 420 thing, just because we want to make sure it's a good workflow, because right now these things are identified under the hood by their name and what layer, if they're in a layer or blend, and what index they are, and you don't want to have to like go update that manually every time you move.
I mean, we could potentially add something just so it's there, but it would almost certainly get removed and redone. So, well, it's like with this whole system so far, as it is experimental. I mean, we may, over the next N months before 420, we may decide that there's just a much better way of doing things and want to rewrite a big chunk of it. So,
yeah, I mean, even over the course of the 419 previews, like the little filter used to be set in a completely different way, and then we moved it off to this little button to hopefully clean up the UI a little bit. And so I think we're going to see some changes like that along the
And
road.
probably things we can't predict, like
Yeah.
things that we realize there's a better way of doing, or we get feedback on that makes sense. That's, like I said, this is the right time to provide feedback.
Yeah, lots of use cases that we want to see and things like that. Because, like, there's armor, there's things like, environmental effects and landscapes, like so many different possible uses that we want to kind of get input on all of them.
Well, plus it also allows you to, like, Paragon and Fortnite have events that occur to the character, like you've been hit or electrified or whatever, and all of that had to be implemented in this monolithic character shader so that at any time it could be turned on. And being able to do that as a layer, that even if it's not dynamically turned on and off, but it's just, you can choose whether or not it's part of your stack, right? I have a shader instance that implements, the top layer is just an overall damage effect, and then its blend is just a scalar parameter for a percentage. That makes it really easy for artists to opt in and opt out of behavior, to test things without necessarily making a change to somebody else's shader or having to re-implement all of somebody else's behavior. So you start looking at layers as utility objects, not just how your character is going to look, but also a way to inject a certain behavior at a certain point, whether it's gameplay driven or artist driven or pushed by blueprints, whatever.
As you touched on dynamic layers, that's something that comes up as a common
I specifically
question.
didn't say dynamic.
So I just wanted to clarify that, so that comes up as a very common suggestion. It's definitely not in 419. It may come in 420, but right now I don't think we're going to target that unless the overwhelming feedback across the board is we need dynamic layers. Then it's probably not going to happen.
Again, feedback. We like getting feedback.
Like if the whole chat is 10 pages of we need dynamic layers, it's
Right,
probably what's
it's
going to happen.
probably something we need to look at.
It's the kind of thing where, so right now, for example, you add your layers, it builds the graph under the hood. We'd probably look at doing some sort of dynamic layer, so you can check a box, and that would, dynamically try and switch it on and off without creating a new material. So there would be a slight overhead to having that layer, even when it's switched off. But it would allow you to swap it at runtime, which would, for things like those hit effect layers, would be really
Right,
awesome.
because right now, anytime we implement that in a character, we pay that cost all the time, right? If you do something where when your character's hit, there's a big vertex shader that gets applied so that he deforms away from it, that code is being run all the time. Every time that character's rendering, those pixel instructions are and vertex instructions are being executed, even when they don't have an impact. So being able to layer things like that in and only opt into that cost when you actually need it can become very compelling.
One thing that I didn't mention, but with all the talk of characters and hair and skin and things, is within the base shader, everything's got to be the same
Blend mode.
blend mode. So you can't say you probably wouldn't want to put your skin and your hair
Right.
into the same stack.
Yeah, you're not going to build your entire character in a single shader and then just expect the layers to fix all that. So you will still have, and even in here, if you look in the material instance for this, I can still override the blend mode. So I could have my opaque version of my character shader and then also a translucent one as an instance of that, and then opt in for, like, the character's head has the translucent version for the hair, or, if I have, say, masked wings on my character, I can do that. So it still has that flexibility. It's just you shouldn't expect to have an opaque, translucent, masked, opaque, translucent, opaque type of stack in your shader.
Right.
You just plan for all opaque and then all translucent and all masked or something like that.
Yeah, like this is one material applied to the whole mesh, but for things that are more complicated, you probably will still have,
You ultimately still need to split the draws, to
Right.
swap the blend modes.
For core material changes, not just for a different layer stack or something like that.
Yeah, they kind of mentioned, they're asking, how would I implement a wetness layer with the new layer system when he can't control the wetness through a dynamic parameter?
There are options for that. So in full release, you will be able to, so that's fine. With this one, there's a couple of options. Probably one of the easier ones would be either you can abuse whatever the base kind of material attributes that goes in, and you could pass something through in one of those channels and pull it out in your material. Or there's a shared input system that was added. I believe it's talked about in the forum thread as well. And that's a temporary solution. We'll probably end up removing it for something better. But what you can do with that is you can pipe, say for example, a parameter on that top level material graph into a shared input, and then you can pull from that shared input in any layer that you want to, and if it happens to match up, it will let you use it. So that way you could have a global wetness parameter that passes through. So it's not that it's a good solution right now, but
there's a way of making
Yeah, it'll kind of work
and
around
in
for
a full
now.
solution.
Yeah, it'll
Yeah.
be something nice, like,
Yeah.
you'll pick your, like a more drop-down style.
Right. It'll be, here's the layer or blend this parameter affects, and then you just have a,
Yeah.
like you would any other
Yeah.
material attribute
Set
in
param name, like
blueprints.
layer name
Right.
or something, and set it. Yeah.
Yeah. Yeah. That'll be, well, I mean, kind of critical. We do a lot of things with
No,
blueprints.
we definitely want to get to there. We just wanted to make, not put
Well,
in something
you
that
want
have
you
to
want
take out.
this
Yeah.
to be stabilized, so we know where everything is going to land before you start additionally adding on utility code after that.
Can we animate the blends
Yeah,
in the layers?
Yeah,
I assume so.
there's
Yeah.
actually a panner blend. I haven't looked at it, but I noticed it in here. So it's
The
just
different- It's a little.
so that this isn't like, this is the alpha mask that will blend those two layers panning together. It's used on,
I think the little glowy.
Yeah, the
bits-
blue strips
yeah,
here.
yeah, yeah.
Yeah. So any parameter
Yeah,
that's
you can-
within a layer belongs to that layer and will appear in those layer params. And the same goes for blends. Any parameter that you put within a blend graph will appear underneath that blend in the layer stack. And
now you can see it a little more.
eventually you'll be able to easily select just that one thing and edit it as well.
It's also
dynamically,
important to note that most of the blends that we're showing are just lerp, right? A or B with some feathering or some procedural behavior. You can additively blend things, multiplicatively blend things. Basically, you have access to the same shader math that you do for anything. If you just think of the two layers as two textures, how are you going to blend those two textures? Granted, the material attributes carry a lot more data than just a texture, but ultimately you're just thinking of it in terms of this is A and this is B, and how do I mix these two? That's it. And you can have a really complicated blend that has a different bit of shader math for each attribute, with base color, normal, emissive, all that stuff, and then just resolves that and passes it down to the next layer. So you can have really, really, bizarrely complicated, like, each red rock blends to a different layer or something like that. Or, red rocks blend roughness, white rocks blend opacity, green rocks blend base color. No, I'm not going to set that up.
Thank you. I saw a
Sounds
couple
like a
questions
tongue
about
twister.
substance.
Yeah.
And I think it's more like for I think right now for the masks and things. So I think Harrison we have a video up about how he did, masks and whatnot for characters. It's something that has come up a couple times as far as like exporting from one and having, how does that come in? We haven't looked at it yet, but that's not to say, I mean, we probably will take a look because we want that to be
Yeah, yeah.
a nice smooth.
Substance particularly comes up a lot, so improving the transition there. I mean, as Lauren said, we want to solidify this first, and maybe we'll take more influences from Substance or other tools, but that kind of, export, import, or live link or whatever becomes years from now. I mean, we're not there yet. So.
But maybe get there. Maybe we'll get there. Let's see. That was going to be my next question, and then you just jumped on it.
Sorry.
Gosh.
Well, it's something that I think.
Lauren, crushing people's dreams since day one.
No more
You
feature
guys have
requests from
been
you, Alan.
really good,
Good.
at anticipating.
That'll make your life easier. Sorry, Lauren.
No, I have a lot of things I want to put in.
Yeah.
Yeah. Reordering is one of them.
I'm looking forward to that one.
Reordering.
Yeah, like being
Oh.
able to take
Yeah.
the leather stack and drag it down and
Yeah.
or if we don't have drag and drop, just kind of push it up and down in the array. I don't know. I got to see what.
I have faith
works.
you'll make it work.
You just don't want to do the UI.
I
Someone
have
asked-
faith that both of you will make it work.
Everybody, team effort.
Yay.
They were wondering, can we add, is it textures only, or can we add 3D model layers?
Well, I mean, the material system only deals with textures and
right.
It-
constants, vectors, things like
You-
that.
You're defining like the shading of it.
Right. You're basically you're controlling what the surfaces look like. So while
Or,
there's vector behavior that can be passed through there or vertex behavior that can be passed through as well. So if you had this shader makes things contract or expand or ripple or whatever, that can be layered as well because that's part of the core shader graph that's being kind of assembled. But there's nothing that I can't put a layer that has rubble meshes in it and then draw
Well,
that on. That would be a different system.
hold on. To expand on the question, a weapon on a player's back, depending on which weapon they picked up, the layer will set or add that model instead. So, can they? No.
Well,
it
I mean, the
doesn't-
weapon
yeah,
itself.
that's totally a
yeah.
different system.
I mean, you could.
I read the question wrong.
Ultimately, once all the blueprint behavior has been
Yeah.
implemented, you could have you could change what material is assigned to the player. Like if I pick up a rocket launcher, if it makes my armor red or something like that, you could parametrically drive things like that.
Right.
But you can do a lot of that in blueprints currently,
Differently,
right?
yeah.
You're basically looking at, has this condition been met? If so, set these scalar vector, texture, material assignment, whatever, on another asset.
Yeah.
They're curious if we could add a feature. Here you go.
We
Where you would
asked.
bake a layered material into a non-layered material graph, so they can edit the resulted layer material.
Within reason, yes. I don't know what we ship, but for example, Ryan Brooks has made a lot of helper things that do exactly that.
Right.
So
He's writing his own blutilities to
Yeah.
to,
The-
to
the-
do
you
it
know,
with textures, to do it with shader graphs, things like that.
So within reason, because say if you did something and you wanted to keep certain layers dynamic or animated, like the example before, you'd have to manually separate those out and minimize what you can. But yeah, I mean, it's similar to what I was talking about before, where I was saying we haven't really looked at optimization. Like once we know it's a layer and we know it blends in certain ways, we can look at future optimization. Maybe we'd move it into there, or maybe we'd always keep it separate and it'd just be this you can bake things down system for like LODs or something.
Nice. Let's see. So they're asking if world position is inherited from the parent to child, so that the
Yeah,
children
world
may
position
modify
is-
the existing.
World position is passed in by the engine, so
Yep.
the pixel position is based on the asset's location in space.
Okay.
So all of that will be maintained. I mean, you could always do things to the results of world position that get passed down in the
Yep.
layer, but the core data that's coming in will be identical for all layers, provided they're assigned to an asset in space.
Yep.
The things, all the things. They're wondering if at some point you could potentially, so right now you only use the RG. I'm gonna take another stab at this, guys.
Got this.
Can you only use the RGB channels to blend between layers? So you're limiting it to 3, well, plus alpha, so you have 4 theoretically, or potentially. Or is there a way to do color picking where you can use gradients of colors to pack more IDs?
So you can do the gradients thing too, and
Yeah, you just have to do shader math to go to basically threshold values and say, if the value is between 0.4 and 0.8, then that will kind of take that and make that the blend between these things. We do that all the time. Channel packing is just a really convenient, easy way to not only store the data, but visualize it and use it. And we do all sorts of stuff like that in normal shaders to kind of use different portions of a texture and different values within those portions for different things.
Well, the reason that channel mask parameter went in is because somebody was just doing kind of the basic multiply by a vector, and they didn't want to get a vector that was close but not quite to blue, and then get a mask that
there's
way.
already
it's a very
a
common operation.
and there's a static component mask, but that requires
Which was
permutation
why we added
recompiles.
this one to
So
get rid of it.
the channel picker is way better for this type of behavior.
Yeah, and I mean, so ultimately as well, like it's probably one of the most common examples is to take, you know, a set of masks and just pick a channel and multiply it in, because you get a nice gradient and whatever in it.
Yep.
And that's why so many examples use it. But yeah, I mean, you can do whatever you want.
Yeah.
That's the beauty of it.
Yeah, I was telling Alan an example. It's like you could take, you know, the emissive from one and the base color from the other and chuck every other thing out, and that can be your blend. So
Anything you want.
Yep. There's all sorts of stuff that can be done.
Yeah.
I can actually just hook this directly out.
Will the layer system work with a forward renderer?
Yes.
There's an
Yes.
easy answer. Yes.
Yeah.
There you go. Ta-da.
Nice.
Shiny.
All right. Well,
Gonna get Disney mad at me.
it's so pretty.
And then I can go in and, because the blend has parameters, I can change the tiling of this pseudo.
carbon fiber over carbon fiber. Yeah.
So
My carbon fiber shield impact effect.
Yeah, there you go.
can you get electrocuted? Yeah. Well, that's about the end of our questions.
Yeah.
Before you get into,
He made me want
is that the one
armor.
we'll make for you?
Purple.
I didn't yell though. Hopefully.
I heard you.
So thank you all so much for joining us.
Our pleasure. Or
think
mine,
there's
at
a
least.
lot of-
And I think Chris was a little nervous because it's his first time on camera, but I think
Yep.
you did very well.
Thank you.
Good,
You're
thank
welcome.
you. It's always good to get varying perspectives on the tools, and so it's great to have all
And
of you
I
on
mean,
and
this
a
is
full
like
studio.
the
This is the-
perfect storm, right? Implementing core shader UI and actually using it. So
There we go. So now, like, you're the one that gripes at them, and it's full cycle.
I gripe at Lauren. Lauren then tells Chris what I need from him.
And then he just sits there and is like, artists.
It's safer that way. It really is safer that way.
All right. Well, if you have feedback for us, whether it's on any of that, just how our live streams are doing, I'm actually going to toss a survey in, and you can let me know what you'd like to see in the future. If you'd like to see their lovely faces, if you're tired of them, like, let us know what kinds of topics you want to cover. And then, as always, please submit your projects to the NVIDIA Edge program. We're always on the lookout for really stunning, beautiful visual projects. Additionally, make sure to see what local meetups are going on in your area. If you go to meetup.com/pro/Unreal Engine, you'll see all the different groups that are available, what's in your area, and what events are going on. And that's it for today. So thank you all for joining, and we'll see you next week. Bye.